Alright guys, today we're doing something different. Welcome to the voice reveal. Yes sir, this is Robovidrio. Today we'll be going over our recent project, SlowPoke bottle opener table stationery, modeled by Remtoto and brought to life by Robovidrio using the Makera Carvera CNC with the 4th axis module. As most of you know, I make cutting boards with laser engravings. I cannot bring myself to sell low-quality cutting boards, so let's start using them for other things. I calculated the maximum sized cylinder I can make from this failed cutting board. Check out my channel to see how I make my cutting boards. I calculated I needed to make a 76mm diameter by 160mm tall cylinder. I then split this part in 3. In VCarve, I added the 3 parts. In the middle, I did a simple profile. Alright, so let me try to explain. You select the 2D profile toolpath, you select the vector is 76 by 160, and you select the bit. The bit we'll be using is a very dull bit. It's tool number 1, it's 1mm depth, 12,000 RPM, we don't want to hit maximum or it might overheat, and 600mm per minute. We are going slow since the bit is dull. The stock, the piece of wood, the cutting board, is 25.5mm thick. And we want the profile toolpath to cut straight through. And we're going to select outside of the line. We don't want to cut inside of that line because it will give us a different measurement. Outside of the line to achieve the 76 by 160. Direction does not matter, and since we're cutting slow, we don't need tabs. Tabs is for holding the piece in place, and since we're going slow, the piece is not going to fly away. It's not going to move. Alright, next up will be the side pieces, the left and the right. We'll be using a roughing pass, 3D roughing pass, to create the 3D model we created. And we'll be using a vector slightly larger than the piece we'll be cutting off. So the larger part's going to be around 80mm by 170mm. The interior vector is going to be 76 by 160. So we select the outer one, the bigger vector, and we select the selected vectors, and we go back and select the tool bit number 1, which is the 1mm depth, 60 over, and next. Then we machine with allowance of 1mm. I like doing 1mm. You can do 0.5 or you can do 0.0. We'll be doing a 3D raster at 90 degrees to prevent cutting with the grain. We want to cut against the grain. Ignore that warning. And this is against the grain with the real life stock. The grain is against this toolpath. This is the simulation. You can see the top corners are rounded, roughed out. This is what we need. We don't need it to be perfect like the 3D model. Now we can do a 2D profile toolpath to cut it out. Again, 25.5mm deep. We'll be using a dull bit. Select the interior vector. The interior vector is the 76 by 160mm accurate part. Alright, the concept is simple, but I might need to explain this. I am human, and I cannot clamp this cylinder down accurately. So what I need to do is clamp it down as accurate as possible, simulate a cylinder slightly bigger, and mill down the simulated cylinder until it starts milling down the actual physical cylinder I have in front of me. Let me show you. The simulated cylinder is bigger than the actual physical cylinder I have in front of me. In the simulation, it starts milling down the cylinder, and when I notice that the bit starts hitting the physical cylinder, I can stop it and accurately feed it information on how big the cylinder is. And then we can start the project. All right, so this part is going to take some time to explain correctly. So we have the model here, the SlowPoke, that was donated by Remtoto. I stuck a cylinder in its ass so it could have a strong pull to be supported on. We'll click on Roughing Machining Toolpath, since we're roughing the 3D model, and we're using bit number 1 as before. You can pause it to see the information. We're going to rough it, so it's going to be a 1.0 millimeter allowance, and with a raster. So let's see the simulation. Here's the cylinder. The simulation runs. This is the roughing with the cylinder in its ass. We're going to have to cut the front portion. We don't want that. So let's try to figure this out. First, we need to mill down the front portion. Here's the rectangle. It's going to be milling down the front portion. And we're milling it down to prevent the spindle from hitting the cylinder, because the bit is not long enough to cut it all off. So we're going to remove part of it down a bit. There, we have clearance now. Now we can stick the bit down deep until it cuts down. There we go. Then we remove that part. In real life, right now, it can't be removed. And then we're going to cut it real close up to the mouth. You're going to have to try several times in this simulation to get the accurate location. But that's the accurate location. Here's the line. The line is right in the front. Just move it around until you find the perfect location. All right. The simulation for the finishing pass. The finishing pass is only going to be the front. We don't want to touch the back, because the back is the support, the thing that's holding it in place. 3D finish look is bit number 3. It's the ball point at 70 degrees, I believe. 70 degrees. 2 flutes, 40% step over, 12,000 RPM, 15,000 is the limit. We don't want to hit the limit. The feet rate at 1,500. It's not that great. It's slow, but it gets me the quality I want. Here's the rectangle, the selected vector that's going to finish off. We want to finish just the front, not the back. And we're going to have a raster of 0 degrees. This is what a raster of 0 degrees looks like. The tool head, where the spindle is, moves while the platform, the 4th axis, rotates once in a while. We don't want to put too much stress on the 4th axis module. This is the finishing pass. All right, so we got the front done, and we cut off that front piece. Now let's work on the back. So you need 2 models for this. You need to replace the model we had right now with the cylinder in its ass and put in a model without the cylinder in its ass. But before we can finish the back portion, we need to make some clearances. This is a pocket. We're moving material so the bit can reach real deep down. In the video edit, I'll show you how deep it goes, almost to the limit. Again, we're going to select the vectors, and we're going to rough out the cylinder part. This is the information you need. We're using bit number 1. It's very dull. I've been using it for lots of projects. It's very dull, so we're gonna go slow. It gets the job done. I don't want to replace the bit just now. So we select the vector where the cylinder is that we need to remove. We're gonna rough out that cylinder. And since most of the roughing was done already, it takes some time before it reaches the actual part we need to remove. And there it goes. They removed this cylinder, the thick cylinder. Now there's a very thin cylinder that will snap if we're too rough. So we can't do any more roughing. We got to do some finishing passes. 3D finish. Again, with the ball point, here's the information. And again, we're going to select the vectors. We don't want to touch the front. We only want the back. We only want to finish the back, that portion at a raster of 0 degrees. Again, this is how it looks. And we are done. The pocket, the holes for the bottle opener, I'll be doing another tutorial for that. It's the same concept as my bottle opener, egg rose bottle opener. Same concept, same thing. So there's nothing to show here right now. And that's it. Then we run a pocket to remove the piece of wood that might be holding us back. And then we do a profile, a line right down there. A line to cut real deep and remove that tail as close as possible. We run that profile extremely fast. And there, boom, it's done. Now the video edit.